Okay, here we go, tutorial number 16. This is going to feel like a review because while we are working on graphing quadratics, we have graphed quadratics before. So it shows up again in our quad unit, and we're going to repeat what we've learned before and what we've become good at. And then we're going to learn something new the next tutorial. But let's go ahead and review how to graph this type of quadratic. Remember, in our lesson, we had a lot of fun with Desmos, and we found out things like this. When you put y equals x squared into Desmos, you get something like this. All right, I made it a little extra. But remember, there's a pattern because it's x squared. When you move one to the right and one to the left of the vertex, which is our vertex, then you go up one because 1 squared is 1. And if you move 2 to the right or 2 to the left of the vertex, you go up 4 because 2 squared is 4. And if you move 3 to the right or 3 to the left then of the vertex, and you go up 9 because 3 squared is 9. And so we use that pattern to help us to graph any quadratic that was thrown our way during that unit. And so another thing that we learned during that unit, besides the pattern, was we learned that when we have a little something extra, this plus 9, that had an effect on the vertex. So instead of the vertex being down here on the origin at 0, 0, it was moved up 9. So there it is right there. And now we learned another thing. We learned that sometimes there's going to be something in front of our x squared. In this case, it's a negative. Sometimes it's 5 or a negative 1/2. But that's going to mess with the pattern. And so a simple way to think about it when we see a negative is that it takes the whole graph and it flips it. So if I were to see this, and whether in my practice or on the test, and asked to graph it, the first thing I would do is find where my vertex is. So just like we reviewed, this plus 9 tells us the vertex is no longer on the origin like the parent function, the quadratic parent. We're going to be moved up all the way to 9. And instead of doing my normal pattern that looks like this, my pattern is going to be multiplied by a negative, or you can think about it as multiplying by a negative 1. So instead of going to the right one or the left one of the vertex and going up, I'm going to say up 1 times negative 1, which gives me down 1. So we did a version of this. Same thing if we went 2 to the right or 2 to the left. Instead of going up 4, I'm going to go 4 times negative 1, which is negative 4. So I'm going to go down 4. 1, 2, 3, 4. And let's do one more just for fun. If I were going to go 3 to the right or 3 to the left of the vertex, I would normally go up 9. That's the pattern. But this time, because of that negative, it's 9 times negative 1. So that means when I go 3 to the right or 3 to the left, I go down 9. Whoops, I should be at 0, shouldn't I? Went down 10 instead of 9. So went down 9. And there you have it. All right, that was a little messy. I should have tried to hit all the dots perfectly. So hopefully that's coming back to you. This has one new thing. In addition to the vertex being moved up, we've got another number here. And so let's review real quickly what that second number means. When we see a number inside parentheses with x before it's being squared, that number is going to move our vertex either left or right. And we learned in nonlinear graphs that it's always the opposite when we're moving left to right. We see the minus here, and that means, believe it or not, move the vertex instead of at the origin, move it 5 to the right. So there's my new origin. And so, I don't know what are underneath these graphs. Okay, so this is showing us that if you've got move to the right and up 6, well, that's what you're going to do. You're going to take your vertex, you're going to move it 5 to the right and up 6, and you have a new vertex. So let's go ahead, and this talks about the pattern that I talked about in the last slide. You can read that and pause it if you want. So I'm going to go ahead and graph this on this graph. I'm going to move my vertex to the right 5 and up 6. So from the origin, I go to the right 5 and up 6. That's my very important vertex. And then I noticed that this -3 messes with my pattern. Every quadratic has the same pattern, and if there's something in front of it, in front of the x, that's going to mess with our pattern. So normally when I go move one to the right or one to the left of the vertex, what do? That's right, I normally go up one, but in this case, instead of going up one, I have to do 1 times -3, which means -3, so that's go down 3. So I move to the right one, I go down 3. I move to the left one, I go down 3. And then my normal pattern when I move to the right 2 or the left 2 from the vertex, I normally go up 4. But now, instead of going up 4, I go 4 times -3. 4 times -3 is -12. So that means when I move to the right 2, I'm going to go down 12. When I move to the left 2, I'm going to go down 12. And there we have it. I can't do any more points because we're going to run off the graph. So there we are. All right, so that should be a review. This next question is going to test whether we understand what we've been doing. So the next question says, take the same equation, so that's the equation we just graphed, and identify where the graph will have y values of -6. So we can cheat because we did such a great job graphing. We can cheat and just look at the graph and see where does the graph have a value for y that's -6. So you see these 2 points right here? This point is, well, let's see if I can do this right. It looks like it should be, if that's 5, 4, 3, that should be 3. So that point is 3, -6. And this point is 7, -6. Can you see how these 2 points are on our graph that we just, our quadratic that we just graphed? Well, that's what this next question is asking me. It's saying, and you know what, so I don't have to keep going back and forth. I'm going to copy this. Let's see if I can do this. Whoops, come back. That's not what I wanted to do. All right, let's undo. And no, let's overdo. Okay, let's see if I can copy it this way. There we go. So I'm going to copy this graph and bring it with us to the next page. So copy it so that we can better understand what they're asking us. So they're saying, identify where the graph will have a y value or y values of -6. Well, we're done. We looked at our graph and we see that at 3, oops, my mic fell off. At 3, -6, and 7, -6, those are the 2 points that have a y value of -6. But we're going to need to show that we can do this algebraically as well. So let's go ahead and do it algebraically. If they want to know where, what x values give me a y value of -6, all I'm going to do is plug -6 in for y, and I'm going to solve. And you know what? I'm good at solving, and so are you. We've been doing this a lot, right? Solving quadratics. So here we go. Let's go ahead and subtract 6 from both sides because we're going to use the square root method to solve this. And sometimes that's tough to see, but after some false starts, I think everybody would agree that the square root method is the way to go here. We divide both sides by -3. And I'm going to go ahead to get x out of there. I've got to take the square root of both sides. And I'm going to remember when I take the square root of both sides that I need to put a plus or minus in front of the number that I'm taking the square root of. Square root of 4 is 2, but I'm going to do plus or minus 2. And remember what we did here. When we have, it's fine to have the answer x equals plus or minus 2, but it's not fine to have x minus 5 equals plus or minus 2. When we were solving these quadratic equations not too long ago, we were splitting them up into 2. We said, well, either x minus 5 equals a positive 2, or x minus 5 equals a negative 2. That's what this equation here says. We have 2 options. So let's go ahead, add the 5. We get x equals 7. Add the 5, we get x equals 3. Let's see if I can get these answers in the same window. So we got x equals 5 and x equals 3 and x equals 7, which is perfect. So where does this graph, this equation, have a y value of -6? At 7 and 3. Now see the way I wrote it? I wrote it as a coordinate point because that's what they asked for. And they just said, hey, at what x's in this graph will give me the y value of -6? I would say 7 and 3, and I would be done. But it says write your solution as an ordered pair. That just means we're going to take our answers, our two answers, 7 and 3, and we're going to put the -6 in the y's place. And that matches up beautifully with what we already knew. Those 2 points are there. Do you have to, because we're such good graphers, do you have to take the time and do this algebraically? Yes, yes you do. Because at some point we might face graphs that are not so easy to find the answer, and we'll have to know how to do this algebraically. Just trust me. All right, I think this is it. Great job and have fun practicing, and I will see you in the next tutorial. Thanks for joining me.